Hello. So today we are going to discuss how GANs work. So let's start. So basically GANs are type of generative models who try to generate real data. So how does they work? So firstly we have let's suppose we are working to generate images of fake currency, but we want the currency to look as real as possible. So firstly, we let's suppose we have a data of real notes. Let's suppose here this is the currency, and we have two networks in the GAN. First is discriminator network, and the other is generator network. The discriminator network basically tries to differentiate between the real data and the fake data. So let's suppose if I pass this real data or real images of this currency, the network should output that this currency is real, so it should output 1. And if I pass any fake currency, it should output fake. Now we have the generator network. Let's suppose we have some random noise here, and we pass that noise to the generator network. And this generator network will somehow generate the images of currency, which will obviously be fake, and we will pass it to the discriminator. Now for our generator to generate good images, uh, it must have to fool the discriminator network. If it can fool the discriminator network, then our generator is good. If it cannot fool the discriminator network, then there must be some problem with our training or how we have made the whole model. So both of these models are can try to learn simultaneously. So let me give you another example, and let's see how the generator network generates these fake images, or we can say it tries to generate the real images. So we take a random vector. It can be Gaussian or from normal distribution. So let's suppose this vector is of length 10 or 100. So we have generated some random vector, and then we have some fully connected layers, and we can attach transpose convolution layer. Let's suppose our images of the currency were of 50 by 50 dimension. So we will attach transpose convolution in a way that it will generate the final output of 50 by 50, 50 cross 50. Now in the start of the training, it will obviously generate some random noise, or that image will not make any sense. But as the training goes, we will see how it improves itself. And now it has generated some fake samples. Let's suppose we have noise of length 10, and we have generated 100 samples. So let's suppose we want to generate 100 fake data samples or 100 images of fake currency. So we will have data of 100 cross 10, 100 rows, and each of length 10. 10 is the length of our random vector. Then we will pass this, and we will have sample of 100 images of 50 cross 50. Now we will pass these to the discriminator network. Now here we have let's suppose our discriminator network, who is a simple classifier, which classifies and gives you output of 0 or 1. If it's a real image, it will give you a value of 1, and if it's a fake image, then it will give you value of 0. So we will pass our fake data, or the data that we just generated using the generator, to the discriminator network, and we will also pass our real data. Let's suppose here we have our real data. uh, let's suppose here we have our real data. We'll pass the real data and we will pass the fake data, and we will try, our goal is to make this network to accurately classify the fake currency and uh, the real currency. So uh, how will loss function help us in doing this? Let's see. Firstly, let me go through this loss function that you will see everywhere, which in first glance you can't understand it how it works, but let me give you an easy explanation of this loss function. So let's suppose we are using binary cross entropy, and uh, if you don't know the formula of binary cross entropy, let me write it here. So if the data is real, and this is the formula for binary cross entropy loss that we will use here in this network. Plus 1 minus y into log of 1 minus uh, h is our prediction. So firstly, let me tell you how this cross entropy works. So let's suppose we are this is binary cross entropy formula. Let's suppose we are trying to classify, we are doing a binary classification. So let's suppose we have two samples. We have two samples. First one, the true label for the first sample is 0, and the label for the second sample is 1. And after passing our data through some network, which can be any network, we get the probabilities like this. We get the probabilities like this: 0.1 and 0.8. 0.1 means that it leans towards the 0, and 1 means it leans towards the 0.1. 0.8 means it leans towards the 1. So how this will work? So firstly, if our true label, here y represents what your true label is. So if the true label is 0, then this part of the loss will not work. This part, the first part, this part of the loss will not work. Then we will go to this 1 minus y is 1. That means this thing will work. So log of 1 minus h, our prediction or the probability that we got from any network. This can be a neural network with softmax or activation functions, logistic this can be logistic regression or the classification. Okay.